So today we have a great panelist, and we are talking about Crosschain DeFi, right? So yeah, let me introduce the panelists first. Try is Yorke from Hyperlane. Thank you so much. Joe from Tackle Crypto, Sergey from Axelar, and Alex from Composable Finance. With Bryan from LayerZero Labs, and we have NoSleepJon to join us as a moderator. So yeah, let's kick it up. Thank you.
Awesome. Yeah, guys, I'm NoSleepJon, and I'll be moderating the Crosschain panel today. I'm in Anon, and I made a profile picture on crypto Twitter that mostly should post, but sometimes there's research on DeFi and Crosschain, so I think it's pretty fun. So the goal of this panel is to discuss the Crosschain future and educate the audience, I guess. So I guess we can start with Bryan, since he's on the same screen as me. How would you explain Crosschain Interop to a non-crypto native?
To a non-crypto native? I think broadly, like, it's pretty simple in terms of the systems that are being built, right? When you think about a packet on the internet, it's a very simple mechanism of like some piece of data that's being passed between two computers, right? Your compute, data, compute. Same thing is sort of happening where chains themselves are really just like arbitrary systems of compute. The way I think about cross-chain is like arbitrary contract invocation with a bytes array. That might be a little bit too technical, but really it's just like a way to make these contracts talk to each other, right? Yeah.
Awesome. Yeah. How would you describe like crosschain bridges and interop layers, and like why do we need them in general? I'll turn this to Sergey.
Yeah. So just to repeat, how would you describe interop layers and why we need alternatives? That was the question, right?
Yeah.
Okay. I think we're kind of in a space where there is almost like a pool and demand for interoperability coming from applications, which I think is very exciting to be at that. But it's kind of a reverse of what happened, let's say, during the internet, right? When we had all the protocols developed like 20 years before a single application used them. So, and I think as a result, like the last few years, we saw kind of an array of what I call like Gen 0 protocols being built, right? Like a lot of bridges. I think a lot of them have sort of been compromised one way or another. Many of them are kind of centralized, controlled by small multisig or like a couple of custodians that are running the protocol. All of them were shipped out, very rapidly to the market to really kind of solve the demand issue. But that cannot scale, right? And we need to do better. And I think the next generation of interop protocols is trying to solve these issues. And it's not that different from other, adoption cycles in the crypto space, right? We saw originally when exchanges went live, many of them were compromised and like hacked because everybody was rolling out their own exchange like overnight without kind of security audits or anything reasonable behind it. Same thing in DeFi, I think when it was first rolled out, like first few years, we just saw one hack after another hack. And I think the same thing happened in the bridging space. Like, the demand is what dictated the pull for the technology, and I think a lot of it has been just rolled out too fast, too soon, without proper architectures in it. And I think a lot of the kind of teams here on the panel, right, and in the space are now kind of taking a second look and trying to revisit and think about like what is the right architecture and what is the right security that has to be put in behind these protocols. So definitely looking forward to a lot of the issues being solved.
Awesome. Yeah. Speaking of security, I guess like the elephant in the room is that everyone in here is like a survivor of all these recent bridge hacks. I guess just want to hear some thoughts on all the bridge hacks recently, what you guys are doing to prevent that from happening to your bridge or interop layer. I'll go with Joe. From Joe.
So I'm from Jump, but I was speaking about Wormhole, and as many of you know, back in I think it was January, there was a pretty significant hack, and after that, before that we were implementing most of the best practices for bridge security and smart contract security, generally, but really realigned and tried to push that beyond just best practices. So one of the things that we're pretty excited about is what we're calling the governor module, which essentially, through governance, places limits on transfers between, basically for new chains that are being added, there are like daily transfer limits, which basically puts sort of firewalls and stopgaps that insulates the rest of the ecosystem and the rest of the networks from these, newer chains, newer integrations that we're adding. And this basically limits the blast radius if there is a compromise, really significantly. And it also means that we can move quickly and add new chains, add new ecosystems. We're currently on, I think, about 19 or 20 blockchains right now, and 7 distinct smart contract ecosystems, which is a lot, and it's a lot of smart contracts to maintain, a lot of audits. And this allows us to continue to, add new ecosystems, add new partners without having to expose our existing partnerships to that risk. Additionally, one of the things that we're pretty excited about is we're launching a Cosmos Layer 1 that's going to have global accounting. So basically, being able to track that every single transfer and every single message, it's paired one-to-one with the withdraw, and there's no double spend or anything like that. I guess also just we're built out in the open. All of our stuff is open source. All the development is there for everybody to see. And I guess the last big thing that we're pretty proud of and excited about is we have the largest live bug bounty in the world, across both Web3 and Web2 in general. And we're really very focused on security and keeping the whole ecosystem safe.
Can I contest the bug bounty point?
Yes, I'll go for it.
No, just we announced our $15 million bug bounty like a couple months ago. It's been live. We paid out a couple audits. It's not under Unit 5, but it's like live and available, and we pay the full bounty if somebody ever just split the. So I do want to contest that point that there is a larger bug bounty, 2 actually, one for LayerZero, one for Stargate at 15 million each.
Bridge wars. Bounty wars now. I guess
I can do it, man. Security first.
I guess I'll pass the question to everyone around the panel actually. What do you get thoughts on the bridge attacks, and what are you guys doing specifically with your protocol to prevent that? I'll pass it to Yorke and just go around the circle again.
Yeah, thanks, John. So just to introduce myself, I'm Yorke from Hyperlane, and excited to be here with the LayerZero guys. I think I wanted to briefly touch on kind of just the previous question of why we need interop solutions. We talked about it from kind of the perspective of application demand, but I think generally there's this super fragmented scalability race happening, and there's all these different scaling technologies being deployed that are extremely nascent and extremely untested. And kind of the way some of these systems are built, if one of those new scaling solutions gets an integration with one of these interop solutions, the kind of security of the interop solution becomes, I guess, as strong as the weakest link of the underlying infrastructure, depending on the architecture of the system. And so, we want to be everywhere because we want to allow applications to reach kind of these new user demographics that are excited about these new scaling technologies. Maybe it's a lower fee environment, or maybe there's native accounting abstraction, or maybe there's native stablecoins. So there tends to be different user demographics on all these different ecosystems, and we're trying to allow applications to unify those network effects. But what we're doing at Hyperlane is kind of trying to take an approach to our architecture which isolates the risk between these ecosystems to avoid a situation where kind of one of these underlying scaling technologies having some sort of catastrophic fault causes cascading failure across the other ecosystems. So with Hyperlane, we actually have a security model where we're currently shipping it out right now, but we like to call it sovereign consensus. And basically it allows applications to define kind of the inbound security that they want to require on individual channels from various different chain ecosystems. And so that can be specified. Kind of the default mode that we're kind of operating with is going to be this distributed proof of stake threshold cryptography scheme, where kind of similar to how Axelar works in some ways. We want to allow applications to actually kind of have their own firewalls and their own specification for how they isolate these risk channels, because we think that depending on the user demographic or the application, you really need to have different security parameters and security constraints. And so with Hyperlane, we're trying to build basically the most, I guess, modular and configurable interop solution for application developers to allow them to specify, I guess, security constraints which are specific to their use case. And so in the case, you can imagine if someone were to build kind of a cross-chain stablecoin like USDC, you can have, in addition to this distributed proof of stake attestation, you could require kind of like, let's say, Circle to also attest to those individual transactions over a certain volume of money being moved between some of these ecosystems. So there's kind of like clearly application-specific constraints on what security should be. I think we all probably acknowledge that. And with Hyperlane, we're trying to allow that to be as modular as possible, so that applications can really roll out a solution that is kind of tailored to their needs.
Awesome. I'll pass it to Alex at Composable.
Cool, yeah. So also stepping back to the need for interoperability. So we talked about it in terms of demand from application side, but also I don't think we've talked enough about how interoperability really helps out the end user experience. Because as an end user, it's a pain in the ass having to manage funds on 10 different chains. And every time there's like a new protocol up, well, then you gotta find a new RPC endpoint, and you gotta figure out how to form the right transaction messaging and bridge your funds there. It's a huge pain. So at Composable, what we're working on is building out this, what we're calling XCVM, Crosschain VM. So you go to our parachain, and then through our parachain, you can use our trustless bridges, which are built on IBC, to manage, you can do DeFi operations on another chain, send the tokens back. You can yield farm on another chain, send those tokens back, and basically do whatever you want across all the chains, but you only have to work with one single interface. When it comes to security, so we're building on top of IBC, so it's already a widely trusted solution that's already been used to bridge billions and billions of funds so far. And in addition to that, we are making sure that every core component is audited by reputable companies.
Got it. And I'll pass it back to Bryan.
Yeah, I think security is like one of the most overlooked or disregarded aspects of the entire industry. And I think a lot of the problem right now is that people get kind of swayed by a lot of hand waving, right? So I think there's like a couple of different things to address here. So one is in terms of like operational security, or like how do you approach shipping code, right? And so for us, that looks like every single piece of code goes through multiple internal audits, and then at least one, but usually 3 or 4 external audits. We're pushing $4 million in audits this year alone. And so like that is one whole process, right? It's just like the operational process. Then you have this really interesting component where in an atomic setting, if there's an issue with the contract, you're just wrong, right? The execution happens and everything is gone. In a non-atomic setting, so when you lose atomicity, that little bit of latency actually introduces like a really interesting aspect of just an area to address risk. And so, if you look at the Nomad hack, this kind of played out over 2 hours in slow motion, and everybody watched it happen, and there was like nothing anybody could do, right? The Axelar hack, like any human with their eye could see like, oh, you're giving out $650 million over here, and you have $0 over there, like this is probably not a real transaction. And there's just like nothing that touched this at all. We introduced this thing called pre-crime, which basically takes the state that's happening, forks every chain locally, runs the state transition locally against a set of invariants that an application can set. So like a very simple invariant for bridge would be solvency, right? You're giving $20 million over here, like let's make sure that you have $20 million over here, that the entire system stays solvent at the end of that state transition. And only on that condition then does the transaction go through. And so that is another piece that I think is addressable. And then the third is, we have all these complex systems, whether it's optimistic messaging or like whatever it is that people are building on top of, but all of these, almost every other system just sits on top of upgradable contracts. So it's like a single set of admin keys that can change the security properties for all applications that build on top, which is insane. And I think that's really the broad difference between like building a protocol versus building like a messaging service. I think there's possibly room for both, but I don't think you can talk about security without talking about upgradable contracts, because at any point in time, it doesn't matter what's happening on top of the protocol or what people think they're opting into. If your contracts can be upgraded and the security properties that underlie everything the application is building on can be changed by some set of admin keys, that's, it's literally utter insanity. And I think that also is one of the biggest issues. And obviously multiple bridge hacks have already happened because of admin key issues. So I think that like just the standard of having contracts be upgradable as a default is literal madness. Yeah.
Got it.
Yeah, so
Pass it to Sergey.
yeah, I guess like just a little bit from the Axelar side, right? Like I think when you think about security, it really comes down to kind of 3 layers you have to think about. You have to think about like the right design, the right engineering, and the right kind of practices on top of it, right? So when it comes to design, kind of Axelar is the decentralized proof of stake network on itself. It's powered by the same kind of consensus as a lot of the Cosmos chains and kind of Tendermint-based chains. So you have a very strong kind of starting point that you can start with. We're also innovating like at the consensus layer where we introduce things like quadratic vote into the network, which is pretty exciting, which I think nobody has really rolled it out to the market, even though people have been talking about it, which I think really increases the security of kind of cross-chain protocols. And then on top of it, you have engineering. Right? I think everybody kind of talked here about like audits, and kind of good practices and so on and so forth. And then I think finally, kind of it ends with sort of application layer, sort of security, kind of what I call add-ons, right? You can have your additional checks at the application layer of, what is the invariance you want to satisfy when you're doing cross-chain transactions, what is the additional checks you want to do, or like cosigning and things like that. So I think if you think about like those 3 layers and you manage to think about how to decouple them from one to another, I think you can build a pretty robust system overall. I think again, like a lot of the kind of Gen 0 sort of interop or bridging protocols didn't really decouple the layers, right? It ended up just focusing on like token transfer functionality, and like everything was mixed, like the messaging, the token transfer, the validation, like all in one protocol. And I think it ends up being a pretty complicated piece that it's kind of hard to enforce. So if you think about it, the right layers, if you think about how to build the secure system across each one of those layers, you can compose it together and you can end up with a very, very strong system.
Yeah, I want to quickly touch on this concept of operations and upgradability. I think there's like a tension between, I guess, having contracts which are upgradable and having a system which is agile and willing, capable to, respond to some sort of catastrophic bug in the contract. So in the case of Nomad, obviously, there was this upgrade that happened, but actually the exploit didn't occur right after the upgrade, right? The bug was kind of in the wild for, I think, at least a couple months before anyone actually exploited the bug. And so it kind of demonstrates to us that like there are these bugs that can live in smart contracts that have been audited by reputable firms, but basically have just gone unnoticed. And maybe only once there's a large enough economic value in the system does there become an incentive or a bounty on someone going in and doing a real kind of audit of those systems. And so you need to have some capability to respond. And in the case of Nomad, if they had, I guess, acted more quickly, they could have prevented some of the bleeding. And so I think there is a core tension between.
Ultimately, doesn't that just rely, like, you're saying if the team had acted quicker, they could have done it, but at this, like, with that comes the other end of the lens, which is like, if the team was malicious, they could have just run everything as well.
So I mean,
right?
there's ways
like
to
the trade-off.
there's ways to design the system. I think with LayerZero, there's a pause functionality. So you have a similar capability of stopping the system in a catastrophic.
There's no pause functionality.
Okay, well, I was under the impression there was, but I think generally, like, there's a tension between the way that you design your system to be kind of tolerable of these catastrophic failures that no one can foresee, and it's not necessarily the only, like, I don't think that there's a specific, like, design pattern of, like, only immutable smart contracts that have been audited, which, like, guarantees the security of a system. I think in practice we've seen that's definitely not true. And so,
I mean, that's the role of governance,
existing
to be
DeFi
able
systems,
to
right?
upgrade these things.
No, that should not be the role of governance. So, like, if you look at Uniswap governance does certain things, but the LPs on Uniswap, people using Uniswap have no risk that, like, one day governance will just vote that all their LPs now belong to governance, right? It shouldn't be this adversarial property. Like, migrating, it sucks to be non-upgradable. Like, you think it's fun to migrate billions of dollars from Uniswap from, like, V1 to V2 and V2 to V3? Well, like, that's the price that you pay to have a trusted system. Like that is the cost, right? There's a reason that those systems are built in that way. If you just have to trust some set of governance, like, governance should control certain things, but there's no way that governance should be able to rug all underlying at any point in time, right?
No, definitely. But I think the important piece is that there is some ability for the stakeholders to react to, like, these adversarial conditions. And I think even in the case of, like, upgradable versus ownable, like, what governance has the, I guess, capabilities to do, there's a spectrum. In a lot of systems, like, maybe the contracts aren't upgradable, but, like, the pointers between contracts can be set by governance. And so, the trust assumption doesn't really change just because, like, the contracts are not upgradable. And so I think in the case of Uniswap, like, there's the threat of a fee. Like, there are these things that governance has the capability to do, which are necessary for, I guess, like, the system to be operated in a sustainable way. And I think it's important to kind of.
But to be clear, if a fee was introduced, it would only apply to people post-fact, right? It's not like existing parties now have their parameters changed. It's as if new parties, any new person who went to swap now opts in under new conditions or doesn't opt in, right? Which is very different than changing the rules to let, like, they can't introduce, hey, now when you want to unstake your LP, we're going to take 20%, right? So I think it, like, really, the difference of, like, what is controlled and what that surface looks like is massive. And changing security parameterization post-fact seems like it's far too much.
Yeah, I mean, I think the reality is that for all of these interop systems that we have today, there are some components that are, sort of upgradable, right? Like, you have either the network, the relayers, whatever you want to call it, like the protocol, right? Like, in the middle, that's upgradable. I think kind of just beyond that, I think you really have to think about, like, what is the attack vector, right? And what is the adversarial model that you are trying to satisfy? And then, often when you think about security, you do have to think about clearly what is an active attacker looks like. What are the kind of hot machines that are running this protocol, right? What are the cold machines that are running this protocol? What does the upgrade sort of path looks like behind the scenes, right? Whether or not you're doing the protocol or application on top, whatever that is. And then you have to say, right, like, is my model to protect against the passive adversary? No. Right? My model is to protect against an active adversary. What is an active adversary is going to go after? Is it online nodes, right? Like, is it 2 out of 2 multisig? Is it, like, something else behind the scenes? Is it offline nodes? The attacker will always go for the weakest link, no matter what it is. And I think kind of while you think about security, it's really easy to kind of think about, like, one specific, like, point, but I think you really have to think kind of coherently across the stack. What is the attack vector? What is the adversarial model, right? right? Like how many nodes would the adversary have to compromise, and like what are the stakes behind them?
Yeah, I guess I wanted to emphasize, not to get into like this super heated debate about upgrades specifically. I just wanted to emphasize, I guess, that like I think as an industry, our operational standards are extremely low. You know, the ability for the average, I guess, participant holding, you know, Nomad USDC to actually inspect what was happening with the system, or be able to monitor kind of what's going on in a way that is like, you know, publicly auditable, was like a huge problem. Like no one knew what was going on, but we were all kind of watching it happen over time. And I think just in general, we all need to hold ourselves accountable and kind of raise the operational standard of these solutions, which are kind of crucial to, you know, us scaling the ecosystem and you know, making sure that we're not you know, burning users that never want to come back.
I think on that, by the way, I think like, you know, as an industry working towards that, I would love to see kind of audits being done in a more accountable way, right? I think one of the issues that we find is like, you know, okay, you do 100 audits, sure, but like, you know, the audits have a fixed, you know, budget, they have a certain number of time, you know, that they spend on the audit, and they move on, right, to the next project. And I would love to see a way to kind of incentivize, right, or create some more interesting structure where like the auditors are actually, you know, part owners in some sense of the system that they're reviewing.
Yeah, I think bug bounties go a long way to doing that, right?
Do you see, like, for example, compensation through tokens, or, I mean, most of us have internal audit teams that are exactly what you're talking about, where they're directly incentivized by, you know, they're part of the network, and then also have external audit teams that, you know, oftentimes either, you know, are paid in tokens or partially invested or things like that. What sort of additions to the model do you see?
But I mean, right, like, you know, again, like, I think if you can tie perhaps the value, right, that's sort of being moved or being bridged to the, kind of to the auditor somehow and make them accountable for, you know, not necessarily the whole value. I mean, it's a combination of audit and insurance, right? Like maybe it actually has to be like merged somehow for the industry to function better. But I think the traditional model, like, even though you have people, you know, on the team, like, okay, somebody, you know, kind of missed it and they get fired or whatever, right? Like from there, but yeah, kind of tying somehow the value being moved around these systems to the insurance, the audit, whatever you want to call it, or a mix of it, I think would be, there's something to explore there.
Yeah, I'm glad you brought up insurance, because that's, I think, kind of like you're saying, the gold standard. Once, you know, some reputable insurance company is willing to insure the total TVL of, you know, our bridges for some reasonable premium, that's sort of when you know that there's backstops, not just internally, but externally, and there's, you know, it's not just some auditor firm saying that, you know, this is good, but really people putting potentially a lot of capital at stake. So I definitely agree with that.
And I think like the last thing, I think we talked a lot about security, right? But I think, you know, in some sense, I think like all of us are in the same bucket where we try to convince like the developers in the industry that, you know, we'll make it safe, right? That's the reality. Like people are scared, right? Like developers are scared to use this technology. And again, I do want to emphasize that I think, you know, we've seen this in regular changes, we've seen this in DeFi, right? Until better companies came in, until better processes were put in place. And so I do think like, you know, collectively we'll all get there. You know, it's a matter of time, and like we should be a little bit more patient.
Awesome. I guess I'll do a quick pivot here. We can talk about like how do you think the cross-chain future plays out, assuming that these developers are convinced and you guys support them really well and like help build up these ecosystems. How do you think the cross-chain future plays out in your opinion? I'll pass it to Alex.
Yeah, so cross-chain future, I mean, I think we've already seen that multi-chain future doesn't work out because, you know, everything's so fractured. You're fracturing your user base, you're fracturing your liquidity, you're fracturing your protocols. But the cross-chain future, where there's heavy interoperability, enables anyone to jump in at a specific point or at a network that they want to use, and then through that network, leverage all other networks that are connected. So I think we're going to see people join, like pick a team, pick a specific network that they really like to work on, and through that network, they'll have access to all others. And it's overall going to be growing the pie for everyone rather than splitting up a single pie into many small slices.
So from Wormhole's perspective, we obviously also see a very cross-chain future, but instead of just relying on like various IBC ecosystems, we want to be able to like tie in all of the different crypto ecosystems. But sort of the more long-term vision that's enabled by, at the very core level, how the Wormhole generic messaging works. It's multicast by default, and one of the interesting things that allows us some, I guess I'll take a step back. Most of the interaction patterns in cross-chain right now are hub and spoke models. So let's say the primary contract is on, let's say Ethereum or Polkadot or whatever. And then other chains can interact with that primary contract. One of the really cool patterns that you can get with multicast is essentially a true mesh, where there isn't necessarily a primary contract anymore. Like every contract on the different chains is just as primary. And so like one particular use case would be, the user just wants to be able to, let's say, get the best loan. And so what they can do is send out essentially a request looking for information, and then all of the different, there's a loan market on each different chain, they all respond back, and potentially different parts of the loan are divided between these different chains or things like that. So obviously, it's not quite there yet. There's a lot of practical things that need to be solved in order to get there, but we really don't want users to be locked into not just one chain, but one IBC ecosystem or really anything like that, but be able to leverage the sort of different advantages. Like for example, Solana's really good at compute. Ethereum has a world-class trust and security model, et cetera, and be able to split up the different parts of your application where it makes the most sense, and be able to build some really interesting applications that way.
Yeah, I'd love to touch on this as well, kind of in the long-term vision of what a multi-chain future looks like. I think today we're in a world where users need to know whether their application is using AWS or GCP or Azure, and they actually that's part of the UI experience. They're actually choosing a specific provider for their compute or for their security. And so they need to understand kind of all of these layers of abstraction that really causes the, user experience to be extremely intimidating. Especially if an application is on a chain where the user is not already. They need to now go and acquire funds to pay for gas on that chain. They need to come up with a new custody solution for that chain. They need to kind of understand a whole new set of keys or curves or security model. And I think in future, applications that are built on these, distributed ledgers and blockchains won't expose this to the kind of end consumer. And instead, the application will decide what is the right route for this specific intent that the user is requesting, to where should the compute be routed, where should the security be derived from, and that should not be a decision that the user is making, just as they don't make that decision in Web2 apps which providers they want to be routed through. And so there is it's a emergent property of these open systems that we can allow users to have a preference and specify a preference for these specific providers, but there's definitely a trade-off there. And so I think for me, endgame of interchain composability is actually the user not even knowing necessarily what blockchains their computation is being routed through, but kind of just using the optimal route for that specific intent, whether it's optimizing the route for liquidity on like some swap, or maybe it's if they're just voting or just paying their bills, they don't need necessarily like a super high security environment, but they instead want to optimize for like low latency. Maybe they're in a coffee shop, they want to do a point of sale transaction, $5 coffee. Like you don't need to go through Ethereum or Bitcoin for that, right? Like there's different compute and security environments that make sense for specific use cases. And I think applications and protocols will kind of build these, still open and auditable, but kind of hidden layers from the end consumer who eventually will be powered by these technologies.
Yeah, I guess I'm just kind of curious. How many of you like use like different bridges and like different chains? Okay, so not many. Okay, well, yeah, I think like for those of you that have not used the bridges, I hope you'll never have to. And I think that kind of for those of you that have, congratulations, you guys have been turned into human routers, so you can do the routing functionality. But hopefully, kind of the next generation of applications will allow you to interact with them, wherever you are from any wallet with one click. I think that's the end game.
Awesome. Speaking of applications, what do you guys think are the coolest use cases and applications for Crosschain you've seen or thought about? I'll pass it Bryan here.
Yeah, I think there's a bunch of different angles here. I think we've been pretty impressed. Obviously, like value transfer was the most obvious, and I think getting away from wrapped assets to native assets has been like a really big step forward. So that's something we really focused on with Stargate, because one of like the broad issues is wrapped asset, like the user carries risk with them in the asset. So the user is exposed to perpetual risk as opposed to like the LPs being exposed to perpetual risk, which I think is a model that makes way more sense given how everybody's sort of mental model works and how most consumers kind of interact or their expectations are. They're clearly unhappy when they're out doing something on a chain and all of a sudden their thing they think is worth $1 is now worth $0 because the underlying got hacked and it was actually like a synthetic IOU. So I think like value transfer is very interesting. I think you go a little above that in DeFi. So a lot of people are talking about order routing. Yeah, order routing and being able to access liquidity on different chains or best preference of pricing is interesting. Lend and borrow natively across chains. And we've seen a huge amount, like 50% of our inbound has been gaming NFTs, and there's so many creative things that people are doing on that side, on both the gaming front and the NFT front. So that has been really, really cool to see as well.
Awesome. I'll pass it to Yorke.
Cool, yeah. I mean, I think like the Hyperlane team views kind of most of the existing like Web3 dApp architectures as having basically superior models in a multi-chain environment. And I think that like two things come from this. One, we get, we don't have this fragmented network effects, a problem that we kind of alluded to earlier. We allow users to kind of benefit from the users on other networks. And so in the case of, a cross-chain lending protocol, like Bryan mentioned, maybe LPs or lenders for this protocol have very different security constraints than borrowers. And so it allows collateral to exist on a high security environment while potentially allowing the loan to be kind of moved around to a lower fee environment where the user actually needs to go and pay their bills. And so there's these sorts of models that allow, in a lot of these, in a lot of these dApp architectures, there's not just one class of participant. There's kind of like these often n-sided marketplaces, and sometimes different participants have very different preferences about what they want their UX or their security or their latency to look like. And generally just, if these applications are redesigned with this in mind to kind of allow users, or rather like design the application to be exposed across all these different environments where it makes more sense for interface to actually exist. You meet the user where they are already, and you kind of get this economies of scale and network effect unification that we generally believe will kind of replace a lot of the incumbents if they don't adopt this model. So definitely, like, if you guys are interested in talking about multi-chain dApp architectures, I'm super interested to catch up with you guys after the panel.
Yeah, along that front, I mean, of course, meeting the user where they are. So as a user, maybe this user's only used to swapping things on Uniswap. So being able to leverage these bridges in order to bring value over to Uniswaps to allow that user to purchase whatever tokens he or she wants without having to learn a whole new chain architecture. And then also, yeah, as Bryan was saying earlier, with aggregators being able to split up order flows without entirely seamlessly for the end user. These are all very interesting, revolutionary things.
Also, I want to agree with everything these guys have been saying, but we also don't know what next generation of applications that some of these cross-chain interoperability solutions could come up with. And one of the really core things about Wormhole is that it's built in a very modular way. So at the core layer, it's just multicasted generic messaging, and then on top of that, you can build pretty much anything else. So you can build a sort of a native swapped style bridge. We already have a really great wrapped asset bridge that allows you to compose in ways that native asset bridges don't allow you to. You can build, we have built an NFT bridge. You can build this sort of mesh style architecture, which allows essentially distributed smart contracts to act in sort of an orchestrated fashion. But the main idea is that you can build these additional modules on top in a permissionless open way. It doesn't require changes to the core contract, changes from the core Guardian set, etc. And so basically, if you come up with a great new idea for how to leverage multi-chain, essentially, you can build that on top of this really solid generic primitive. And we're just really excited about not only the things that, the ideas that we have and the ideas that we're building currently, but all the things that, this sort of open space and all the ideas that you guys might have too.
And I guess just to summarize, right, what everyone said, I think if you have used like an application in the ecosystem that has a decent, product market fit, that application is probably going to be rewritten in a cross-chain native way over the coming years, right? Because cross-chain native way gives you an ability to tap into, global liquidity, composability, and just better UX for users interacting with your application, right? So we're seeing definitely a lot of that. And then it gets back to the point, and then there's a second wave of applications that have been built that are kind of don't have a product market fit, or it would not be possible in a single chain, but only become possible when you connecting everything together and have like a global unified view of the whole ecosystem. And I think that will be, kind of the wave that follows that once a lot of these, protocols become more mature. So, but any application that has a product market fit today, I would say, is going to be rooted in a cross-chain native way for the coming years.
Awesome. Yeah. Speaking of product market fit, and like endgame in general, do you guys think this bridge cross-chain space is like a winner take all? Do you think different providers end up in different parts of the stack or different use cases? I think it was a winner take all. Pass it to Joe.
It's a loaded question. I think that probably different parts of the stack are going to definitely be consolidated. It's yet to be seen if the whole space is winner take all, or if there's exactly how that's going to shake out. I would say, in particular, there's a few layers that I can see. That one of them is the asset layer, and this is essentially having assets that can be freely moved between all chains, without having to worry about, like, is this asset non-native on this chain, and therefore any application that I want to build on, can't use this. So let's say like you're on Avalanche, and you have there's a really great DApp, and you want to be able to use your Solana token with that. So maybe it's like a Prism type thing where you're splitting the interest versus the principal in a interest-bearing token or whatever. It's not great if just because that Solana token is not available on Avalanche natively that you can't use that. And so one of the things that Wormhole is championing is what we're calling the X asset layer, which is being able to take a token from any of these Wormhole connected chains and use it natively natively is such an overloaded term, but use it on that Avalanche application or that Ethereum application or that new Aptos application or whatever, without that application needing to know that it's a Wormhole wrapped asset or anything like that. Crucially, why we think that Wormhole's doing a really great job at the asset layer is also that, let's say you take that asset from Solana and move it to Avalanche, and then you want to move it to Ethereum, and then you want to move it to Polkadot. Well, what happens when you bring it back to Solana? Is that now like your triple wrapped, token? Is that going to be a different token than if you took a different path to get back to Solana? Well, with Wormhole, no. It's when you bring it back to Solana, it's the same. You get back the native Solana token, and crucially, at every step along that path, there's path independence. No matter which path you take, you don't end up with different wrapped assets, and this is really crucial for the composability and the fungibility of all of these tokens, and really, we believe is going to allow these ecosystems to work cooperatively together as opposed to getting more and more fragmented.
I guess going back to the question though. Going back to the question though, I don't think it's going to be winner take all for the bridges, but you'll see a handful of bridges attracting most of the liquidity, and it's going to be a flywheel effect that as this bridge continues to attract liquidity and continues to not be hacked, then it builds more trust, and more people will use this bridge rather than using a smaller bridge with less liquidity that now appears less trusted.
Yeah, I think the question of like winner takes all in the liquidity wars is interesting because different ones of these liquidity layers, like Stargate or Synapse has a liquidity layer, have different CapEx requirements and different capital efficiency properties. So I think in the case of Stargate, Bryan, you can correct me if I'm wrong, but there's basically n-squared channels between all these different native assets between each chain. And so as an LP, when you deposit an asset on an individual chain, you're actually kind of distributing your liquidity across these, n outbound channels. And that enables you to have this synchronization primitive where you have, I think it's called instant guaranteed finality, but you guarantee that users will always have liquidity in the channel that they're using, but you actually increase the CapEx requirements. And so I think I guess it's a classic engineering trope to say it really depends on the use case, but I think in the case of these liquidity layers, there's really a broad design space that hasn't really, I think, been fully explored that kind of optimized for these different properties. So if CapEx was an important property, I think we might see, different designs emerge. And generally, I also don't think there will be winner takes all dynamics here. I think in the case of Hyperlane, we're trying to allow for, many different competitive security models and trying to support actually applications kind of specifying their own preference rather than having like a monolithic or like a kind of enshrined security model. And so I think what we've seen maybe recently is that like applications are the ones who have the most power in kind of like influencing these like winner-take-all dynamics because they kind of control what infrastructure their users are actually being routed through. And so I think generally like application will have different preferences, and I think there's a large design space hasn't been explored, but I don't think there will be winner-take-all dynamics here.
But I guess, yeah, just to add to that, I mean, I think again, like, you have to like decouple layers of interoperability, right? Like you have the transfer, you have like message semantics, you have like APIs, SDKs on top of it, you have liquidity layers and so on and so forth. So I think when we talk about, winner-take-all, like you really have to like pin down the stack, right? Like I do think somewhere on the stack, let's say for the message semantics, pretty sure it's going to be, kind of a, not necessarily winner-take-all, but kind of message semantics that's common across all applications, right? Frankly, everybody here like has pretty similar message semantics. You send the message to chain X, you want to call to contract Y. Maybe you have some flags and fields that you can play with, but the message semantics across all the protocols are very similar. And I do think that actually has to be standardized in some sense for the application to continue evolving while the infrastructure can continue evolving on the back end, right? So as an application developer, you want to fix your, semantic standard, and you can rely on that. While underneath it, all the infrastructure can keep on changing, but your application can still keep on working while the infrastructure is improving, right? And I think that's actually kind of pretty critical for all of us to achieve. And so I actually hope that like that semantic stuff like should be just kind of finalized over the coming years.
Yeah, from my end, I think there will be multiple players in the market, but I think the broad market will likely be winner take most. I think there are caveats within that, but I think it's like most dev tooling type things, or even somebody brought up AWS versus Azure, etc. I think some people have dominant market share. And I think a lot of what that looks like really depends on like developer experience and then modularity of the system. So talking about like what solutions fit in this system, or what's that look like, and then like the extensibility of the primitive. But I do think broadly it will be winner take most, like most things are. But certainly there will be more than one active party, almost certainly.
Awesome. We're gonna have to wrap up soon, so I'll end with one last question for everyone around. What is your favorite bridge or interop protocol like on this stage besides your own? No curveball for you guys.
Can you ask the question again?
What's your favorite bridge or interop protocol besides your own in the Crosschain space?
On this stage specifically, right?
Actually, not on this stage, just like in general.
Just in general.
Yeah. I think there's more options out there.
I'll start it off. We've seen a lot of good things coming out of Axelar, and we hope them, wish them the best.
For me, it's probably like IBC, which we're continuing to support. To me, like that's the protocol that if more chains can talk to one another, I think it's great, right? Like it's a direct sort of connection. You can have a lot of assumptions being removed. Like we support it at the Axelar network as well, so the more the better. It's just very hard to scale for various practical engineering reasons. So.
Right. Likewise, I mean, Composable can't claim IBC as their own, but I do think IBC is going to take over the world. I mean, it's basically the TCP protocol for blockchain communication.
You guys are using it, they have to name someone else. That was the question.
Okay, sorry, you're also using it.
Yeah.
Yeah, I mean, I think I want to steal that answer as well. I think IBC was kind of like the OG in this interop thesis around scaling and how applications will have different kind of like requirements for the underlying infrastructure. I think like at Hyperlane we're trying to learn, like take some lessons from IBC, and I think maybe like the developer experience for integrating IBC has been like a somewhat high bar to reach for some teams, where there's been like some chains that have maybe struggled or even faulted in doing some of these integrations, and so there is definitely room for, I guess, like in my head at least, kind of like systems which are I guess optimized for developer experience. I think LayerZero has done a great job at providing that experience, especially like just being able to kind of like estimate gas on the source chain is kind of a nice feature. So I'm going to shout out LayerZero.
Appreciate it. I think I think I'll chime in with everyone and just tip our cap to IBC. I think everybody sort of has the same consensus that like IBC was really great at starting the early stages of what it's doing, amazing within the Tendermint ecosystem. I think it's struggled to scale externally broadly, and I think a lot of that is the reason why many of us are here. And yeah, so the early work done by IBC, really core concept and what it does within those chains, I think is great.
Awesome. I guess that's kind of wrap it. I don't have any more questions for you guys. Unless you guys have something from the crowd, audience. Is there an audience? I can't see.
Yeah, we can see.
Yeah, there's an audience. We can hand out the mic to someone if they have a question. I don't know if anyone has
we have
questions.
time.
I am kind of curious if you'll see any possibly perverse incentives going on within bridging space, where like people bribing or bridges bribing apps to use their bridge over other bridges.
Oh yeah, 100%. It's super common. I think I think you see all the time now people writing checks into rounds and saying we won't write this check if you build on any competitor, or all that kind of stuff. I think that's like very common practice in a way that it should not be these days, where you're like writing checks, but the incentive is not to like let the project decide what they think is best for them, but more like, we'll give you this money, but like only if you use us. I think that is like, I've probably heard 30 stories of it in the last 3 months.
I guess, well, since they're not kicking us off, I'll let you guys show your protocols again. I'll give you like 1 minute. There's elevator pitch your protocol to the audience, to your developers. 1 minute on each, I guess. I'll start with Bryan.
Yeah, I mean, I would rather do Q&A. I hate doing just like the generic pitch. Everyone's been up here kind of half shilling this whole time. Yeah. For us, it's like pure generic messaging, like that's it, right? That's the pitch, is a set of non-upgradable contracts where all developers have optionality to opt into very specific security parameters that can never change. All library versioning can never be changed if you opt into specifics. So all of the controls that you want on the security side and levers, validation layer agnostic, extensible primitive that has things like gas abstraction and pre-crime built in to make dev life easy.
I'll pass it to Sergey.
Yeah, so I mean, at Axelar, we focus on building secure cross-chain communication network, right? So a network is really a combination of permissionless protocol with kind of sets of APIs and SDKs on top of it that allows you to build cross-chain native experiences for users, right? So the end game, like I said, is to allow any user to interact with any asset, any application, on any chain with one click. And we're building the infrastructure towards that.
And Joe.
Yeah, so Wormhole is on most number of chains, on most number of ecosystems, but at the core layer, we're all doing generic messaging, right? And in some ways that's getting commodified. So I'd like to also just take a moment to talk about what's the ideal number of validators. Is it 50? Is it 100? Is it 1,000? Well, we really think it's 0, and we're moving towards that through ZK technology to enable truly trustless bridging, where you're not relying on validators approving these messages, attesting to these messages. We're able to leverage, or we're working to be able to leverage state proofs to be able to do this in a truly trustless way, where there's no one that can rug pull you in that way.
Got it. Yorke?
Yeah, so I think we all share similar goals, so I'll maybe share Hyperlane's kind of specific niche or focus in this relatively commoditized product of generalized message passing. I think we're focused on the low latency, high security, and low cost use cases for interop. So there's kind of a lot of different trade-offs you can make in that space. We're really hoping especially to support the low latency use cases that maybe some of the other, decentralized security models don't necessarily support or have good incentives for. So yeah, if you're interested in that sort of thing, definitely reach out.
And Alex?
Yeah, at Composable Finance, we are building or we're striving to build the best user experience for this cross-chain world, both for developers who want to deploy smart contracts and are cross-chain compatible, as well as end users who want to access functionality across many different networks, but only want to interact with a single user interface and only pay gas with a single type of token.
Got it. I guess that's a wrap. Thanks everyone for showing up, for inspiring the next generation of developers, all that stuff. Thanks for your time, guys.
Thanks. Thanks.
Thank you.
Thank you.
Thank you so much for your Joe, Sergey, Alex, and Bryan, and NoSleepJon. Thank you so much for joining us today.
Thanks for your time.
Alright guys, so yeah, our next speakers and the moderators here already, so please welcome them.